Hey there, this is just a little video that we did, just quick review problems before the test. So I'm not sure why you're watching this. If maybe you were gone and you needed a quick review, that this might help. Alright, so definitely we did some proofs in this chapter, so let's go through a couple proofs, make sure we're ready for that. Looking at this particular example, it says that we have we have a QR congruent to TS, that's marked in the picture with a little hash mark, and then we have those same two segments that are parallel, trying to prove the triangle's congruent. Alright, so by now, hopefully we know that we have to have three congruences in order to prove the triangles are congruent. So right now I only have one. I have to find some others. I'm going to guess that the parallel lines are supposed to be helping me find something, so I'm going to go ahead and look at these parallel lines. You have to be careful on this particular type of picture because you have to get the right angles, the correct angles marked. So I always like to extend my parallel lines and extend that transversal in there and make sure that I'm picking the angles that are created by those segments. Because like this angle right here, this one is not being created by those. It's not, see how I didn't highlight this segment right here? So that's not it. It's this angle here and this angle here. Those are parallel lines cut by a transversal alternate interior angles. Okay, so what I'm going to gain from this then, let me go ahead and write my given here. I always seem to forget that. Okay, and then for my step 2, I'm going to go ahead and say that angle RQT is congruent to angle STQ. Those are the two angles that are created, and that's the if parallel lines. Remember, I'm going to be picky on the test. You've got to have the parallel lines, and you got to get it in the right order. In this case, I already knew the parallel lines, so that's what I start with. What I'm showing is that the alternate interior angles are congruent. I'll go ahead and mark that in my picture that this angle is the same as this angle. Now the other, that's still only two congruences. I got one more, but we should be familiar with they both share a side, so we've got QT congruent to QT. That's my reflexive step. And remember that the order that you do those steps doesn't really matter as long as you get those congruences in there. I got my 3 congruences. Now let's make sure they're the right congruences, because now I have this. Now when I look at what's marked, this was single hash mark, this was single hash mark. I've got 2 sides and an angle, and it looks like it's the included angle. It's between the 2 sides. So I've got a classic side angle side situation. So I'm going to come back, I'm going to write my triangles. I'm going to copy this from the proof so that I get the order of those angles correct, or the order of those letters, congruent to triangle TSQ, and that's by side, angle, side. Alright, so that right there is a classic kind of proof that I might put on the tests there. Here's another proof. Alright, different picture, different statements are given to me. This time, again, they're giving me 1 congruence. I'm going to need 3 because I'm trying to prove the triangle's congruent. But they give me this extra piece of information. They're telling me that AC is perpendicular to BD. Alright, now this one's, I got a couple things I can do here. When I look at this, I know that the perpendicular lines are going to form right angles. And then that's going to get me some right triangles. Now we do have that extra method of proving triangles congruent. If you'll recall, it was HL, hypotenuse leg. But the reason that I think I might not be using that is because they gave me a set of angles congruent. And we don't use angles in hypotenuse leg. So I'm guessing I'm instead going to say something about these right angles being congruent and then try to do something else. And then that I'd have 2 sets of angles. Okay, let's jump in and let's see what happens. I'm going to go ahead and say that angle ACB and angle ACD are right angles. Now the reason I know that is because that's the definition of perpendicular. Definition of perpendicular says lines that are perpendicular intersect to form right angles. Got it. Now that's not a congruence, so I got to come back and say, oh, well, if they're right angles, oops, that was supposed to be ACB, congruent to angle ACD, because all right angles are congruent. All right, so I'm not going to try to be tricky on the test. I'm going to give you some of these same kind of things that we've used a bunch. These are definitely what I'm doing today. The all right angles congruent, the definition perpendicular, parallel lines cut by a transversal. All of those are fair game for the test because we've used those a bunch. Now, just like last time, I've got that extra piece of reflexive I can put in there to get one more congruence. And again, if you wanted to put that right off the bat, because some of you, you see that one right away, and that's okay. If it helps you, go ahead and mark your picture as you write things congruent. So I've got this angle congruent to this angle, and then I've got my reflexive, and it looks like I got an angle side angle. So let's write those two triangles congruent. Again, just copying from the prove statement. And that's angle, side, angle. All right, let's try one more of these. I know these are the hardest things for us, so that's why I'm trying to. This one's a little bit trickier because it's got these overlapping triangles, and that's a little bit trickier. So on this, and if you'll notice, I'm not proving triangles congruent, I'm proving these segments are congruent. Okay. That still means I'm probably going to have to show the triangles are congruent, and then I'm going to come back with a CPCTC step right here for this. Now, the triangles that I'm dealing with, if you'll notice, it uses like this entire angle here. So I'm looking at this triangle, QDA, that triangle. And it overlaps with this triangle over here, right here. Now, they didn't do anything for me on this one, so I'm going to have to start from scratch. The very first thing I'm going to do is put in my given. So I'm going to say that segment QD is congruent to segment UA. So that's one congruence I've got, and that's marked in the picture. And I've got angle QDA congruent to angle UAD. That's all given. That's two congruences. I need one more to show the triangles are congruent. If it helps you on these overlapping triangles, redraw them. Here's my QDA triangle, and then I could do this, redraw this one. I'm going to come over, I'm going to redraw it over here so you can see it. Oops, got kind of wiggly there. Okay, so I'm trying to prove these two triangles are congruent. So I've got this angle here, you can see, that matches up with this angle. I've got this outside leg and this outside leg. Now, I didn't really have anything extra in my given to create another congruence, so I'm hoping there's something in the picture, and hopefully you can see that they are both using this leg, this AD. It's this and this. That's going to be the same in both of those. That's just a little reflexive step. So segment AD congruent to segment AD by reflexive. Now I have my three congruences, and let's see what it looks like in the picture. What I've got is a side angle side situation, two sides and that included angle. I'm going to go ahead and say my two triangles are congruent. Now they didn't tell me how to write this, so let's practice on making sure we get this written in the right order. In the shape of this, you can see that this angle here corresponds to this angle up here. That's Q and U. All right, so the Q and U have to be in the same spot. And this congruent angle here is D over here, but over here it's A. So D and A have to line up. All right, so here I go. I'm going to start writing this. It's going to be triangle. I'm just going to say Q, D, A. That's the left triangle. Congruent to triangle. Q, we said, corresponded to U. The D corresponds to the A. So U, A, D. And those triangles are congruent by side angle side. But again, that's not really my ultimate goal. My ultimate goal is to find a couple other congruences out of that. And they want me to show that QA, this right here, which is really this, is congruent to UD, which is this. And remember that if the triangles are congruent, all their corresponding parts are. So as soon as I get those triangles congruent, I'm going to jump right in and say, all right, I've got it. QA would be congruent to UD, and that's because corresponding parts of congruent triangles are congruent, CPCTC. All right, that's it for proofs. Just a quickie practice of some proofs. Okay, on this one, this was just using some of our theorems to find some missing parts. This says, what is the measure of angle ABC? That's this one right here. Well, here's the deal. They gave me this nice 66, and I could do something with that, but my reality is, oh, wait, sorry. I marked that wrong. I was going to say, why did they give me that 66? They want this full angle, the whole thing. Okay, that's a good question, because now we got to work through some stuff. I'm going to look at, first of all, the thing that jumped out at me is that this over here, this is an equilateral triangle right here. And remember that in an equilateral triangle, all the angles are also the same. So if they're going to add up to 180 and all be the same, this piece right here has to be 60. So I'm going to go ahead and write that. I know that this half of it, and I say half, it's not really going to be half, but that chunk of that angle I'm looking for, ABC, is 60. Now I'm going to use my isosceles triangle over here to come up with the rest of it. So if I were to redraw that, I'm going to pull it out so you can see on an equilateral triangle. If this angle is 66, remember that your base angles are the same, so this is also 66, and they have to add up to 180. So what I would do is I would take 180 and subtract my two 66s. I'm doing this right now, minus 66, minus 66, and I end up with a 48-degree angle right there. Okay, so then that means over here that's a 48. And if I have a 48 and a 60 together, the measure of angle ABC would have to equal 108 degrees. Okay, so used a couple of our theorems on that one. Okay, next one says, what's the value of x? All right, so let's see what they've given us here. The big triangle is an isosceles triangle. You see these two legs are the same. Okay, so I know that these base angles here are going to have to be the same. All right. And it's kind of hard to see that, but I think the 42 is supposed to be over in there. That's a 42, so that means this will be a 42. The other thing I know is that these two angles here have to be the same. All right, so they've dropped this little, it's really an angle bisector. They've dropped that down in there and made these two be equal. Ultimately, if I look at the big triangle, and if I can find angle N, the big angle N, the whole thing, which I think I can do in an isosceles triangle, then I could just divide it by 2 and I'd have the x value that they want. So that's what I'm going to do. I'm looking at this triangle and ignoring that segment in the middle and saying, okay, if this is a 42 and I know this is a 42 because of the isosceles, I'm going to take 180, subtract my 42 twice, and I end up at a 96 for this angle. Now, x is just half of that though, so I'm just going to divide it by 2, and I've got x to equal 48. All right, last one. We've got this exterior angle is 125. Remember our theorem that says the exterior angle is equal to the sum of the remote interior angles. So this is going to equal these two added up. All right, but I'm ultimately looking for this angle up here. It's a nice isosceles triangle, so I know these base angles will be the same. I think I'm going to have to do a linear pair here. All right, if this is 125, what's left for this? Well, 180 minus 25 is going to be 55. So I know that this is 55 degrees and this is 55 degrees. Now I'm back to, and that's the same, remember, because of the isosceles triangle. Now I'm down to, oh, well, and I was saying there's a couple ways you can do this. Now I know 125 equals the sum of these two, so I could just do a 125 minus the 55. I also could say, well, the angles add up to 180, so I could subtract from 180. I'm going to do the 125 minus the 55, and that's going to get me my x. All right, and what you end up with is a 70 up there, so x is equal to 70 degrees. All right. Last thing, I'm not really going to go over it, but what you need to do is you need to take some time, look over your construction packet for some of our new constructions that we did in this chapter, or even some of the old ones. Look through that, make sure you know how to do some different constructions, because I will put those on the test. All right, thanks for looking this over. Good luck on your test.